Here's integrated 3. It's problem 4-56. This problem wants you to solve it by, well, you know you have to get rid of the square root, so you're going to square both sides. But the problem that I see happening with lots of you, with many of you, is that you think when you square a binomial, you'll get just 2 terms, but you're going to get 3. So what I'm saying is that, like, let's look at a binomial. Let's say I want to square x plus y. Some people think that when you square x plus y, you'll just get x squared plus y squared. But that's not true, because you have to multiply x times x, and then x times y, and then y times x, and then y times y. You actually, when you square a binomial, you get a trinomial. So if I wanted to square this, I'm not going to just get x plus 5 plus 5. I'm not going to just square this and square this. I'm going to get 3 terms, not 2, because that's what happens when you multiply. So, and some of you guys don't do it this way. Some of you guys, if you want to square a binomial, you'll go x times y times x times y, and you'll get x squared. You'll get these 2 xy's, and then you get the y squared. So I think you can prove that x plus y squared isn't just x squared plus y squared. It's x squared plus 2xy plus y squared. Okay? So if some of you thought that it would be okay to just square both sides of this like this, some of you are trying to say, okay, I square this, and it's x plus 5, I square this, 5, and I square this. That's not true. Squaring this would give you something horrible. It would give you this times this would be x plus y, plus 5. This times this would give you square root 5 times x squared x plus 5. This times this will give you another square root 5 times square root x plus 5. This times this will give you the nice little 25. So you do get x plus 5 and 25 if you square this, but there's this other middle part. There's 2 of these things. And so that's what it's saying in your book. It's saying that they squared both sides, but they got this big ugly mess. So what you want to do is, what they're showing in the book is, you want to isolate one of the radicals first and then square both sides. So now I'll just go ahead and do the problem the right way. So the right way to do this would just be to get the one of the radicals by itself. Square both sides. Now when I square this, I will just get the x plus 5. When I square this, I'm squaring a binomial, so I'm going to get a trinomial. Okay, I'm going to get, and I don't know if you remember the pattern that we just showed you, but there's a pattern to this. This squared gives me the 25, and this squared gives me the x, but then there's these other 2 things you're going to get. You're going to get negative 5 root x, and this other negative 5 root x, which gives you, I can add these together and get negative 10 root x. So this is going to end up being 25 minus 10 root x plus x. I know, it'd be easier if it worked the other way. It'd be easier if you could just square the 5 and get 25, square this and get x, but you're always going to get that middle term too, which is the first thing times the second thing times 2. Okay, so that's a pattern. Now we're going to isolate the radical. I guess this will give you negative 20. And I can divide both sides by negative 10. And if I want to check my 4, I can check it, and 4 plus 5 is 9, square root of 9 is 3, and then square root of 4, that's 2. 3 plus 2 is 5, so I know it works. And then for the second part, doesn't it have letter B? So that was letter A. For letter B, it wants square root 2x minus 2 minus square root x equals 1. Okay, so we have to we can't just square both sides yet. We have to get one of the radicals by itself. Okay, when I square this, it undoes the square root. When I square this, let's use the pattern. We know it's going to be this squared, and then it's going to be this times 2 because of that, because of what happens when we put it in the box. You know how there's always 2. So it's going to be this times 2. So 1 times root x times 2 would be 2 root x. And then this last term is going to be just x. So I know it's hard because now you got to do it again. So now we got to get this root by itself. So we're going to get everything away from the root. I guess that's negative 3. Okay, and then I can, well, I can either divide both sides by 2 now, or I can just square both sides now, and then I'll have a fraction. I guess it doesn't matter. I'm going to square both sides like this. Okay, so then I get 4x, and this thing is, I'm going to square this out. So I take the first thing and square it, and then I take the first thing times the second thing times 2, because that's what happens when you put it in the little, you know, see, it's like this times 2 because there's 2 of them. So that's negative 6x plus 9. Okay, and then I guess I need to minus 4x on both sides. And a lot of you did okay on this. And you knew, people knew that they needed to do a diamond problem. So looking for something that multiplies to make 9 and adds to make negative 10, 9 times 1. So this is x minus 9 and x minus 1. So x equals 9 from here, or x equals 1 from here. But then a lot of you forgot to check your answers. So when I check with the 9, 2 times 9 is 18. 2 times 9 is 18 minus 2 is 16. Square root of 16 is 4 minus, this would be 3. And that does equal 1. So that one works. Check out your 1 though. 2 times 1 is, 2 times 1 is 2. Minus 2 is 0. Minus square root of 1 is 1 equals 1. Well, negative 1 is not equal to 1. So somehow that one, this answer doesn't work. So the only answer is 9 for this problem.